All right, everybody. This is Mr. Sewell here with kind of an explanation video that goes along with our slideshow, The Known Universe. And so this will be on remote day number 1 material. And I just wanted to take a few minutes and kind of go through these slides, help you understand the concepts, maybe explain some things to you so that you'll have a better grasp of how the Earth does move throughout space. So let's go ahead and get started here. And there's a couple, there's 2 or 3 basic movements that we need to know about as far as the Earth goes. Now, the Earth is spinning on an axis, which is an imaginary line that goes from North Pole to South Pole. And we call this spinning rotation. Rotation, the Earth will rotate once every 24 hours. And so it's the movement of rotation that allows us to have day and night. Sometime during rotation, part of the Earth is facing the sun, and there'll be daylight on that side, and then the opposite side will be facing away from the sun, and of course that will be night during that time. And so if you take a look at the rotation, the Earth actually rotates from a west to east direction, which is in a counterclockwise. If you were looking down on top of the Earth, it would spin in a counterclockwise direction. And so this is why the sun rises over here in the east. Let me turn on my pointer. Yeah, the sun will rise over here in the east, and it will move across the sky throughout the day. And what this graphic is showing you is during the summer hours, the sun is at a higher place in the sky. During the winter hours, or during the winter days, rather, the sun takes a lower trajectory, and that's due to the tilt of the Earth on its axis. We'll get to the tilt in just a minute. And this is a picture of how of various photographs during a summer day of where the sun is at the camera is from a fixed position. And so, like I said, this picture was taken maybe once every 45 minutes or so, and you can see how the sun rises or moves from a easterly to a westerly direction. Because the Earth is spinning, there's a force that is applied called centrifugal force. And what that does is it makes the Earth kind of bulge out in the middle. So scientists have measured the distance from pole to pole and around the middle of the Earth, which is the equator. And the Earth is 27 miles or 43 kilometers wider at the equator. And that's due to the Earth spinning. And so the Earth is not perfectly round, but it's called an ellipsoid. It is spherical in shape, but it's not a perfect sphere. It's slightly fatter in the middle than it is at the poles. And this is just a little graphic to kind of show you how, I don't really know what it's trying to show you, but kind of a neat little graphic. There you go. All right, now we've talked about rotation, which gives us day and night. The second major movement is revolution, which is movement around the sun. And this takes 365 days or 1 year, actually 365.24 days. This 0.24 days we account for this every 4 years. And so every 4 years we have what's called a leap year, in which we add a day on to February. We have a February the 29th. And so, let me go back real quick. So, rotation gives us day and night. Revolution is the movement around the sun, which takes place over an entire year. Now, as the Earth is revolving, it is tilted on its axis. The Earth is not perfectly straight up and down. So you can see over here is the sun, and as the light comes in, the Earth is actually tilted 21.5 degrees. On its axis. So that means that sunlight is not hitting the Earth equally everywhere. And because sunlight is not hitting the Earth equally everywhere at all times, we're going to have seasons. So the tilt of the Earth gives us our seasons. Now, the direction of tilt is going to stay consistent throughout the Earth's revolution. So you can see here's our tilt during June. Here's our tilt during September as we progress on. Here's our tilt during December. And then as we come back around to March, here's our tilt. So we're revolving around the sun, our angle of tilt or our direction of tilt is going to stay pretty much the same. But because we're always tilted 21.5 degrees here, during the revolutionary period or throughout the year, the sunlight is going to shine on the Earth at different angles, which means that we're going to receive sunlight in different amounts. So during our summertime in the northern hemisphere, we're pointed towards the sun, which means we're receiving more sunlight. And so we have longer days and we have hotter days, and we call that summer. During the opposite time of the year, we're pointed away from the sun during December or during the winter months, which means that we're receiving less sunlight. So we have shorter days, and those shorter days are less intense when it comes to heat. So we call that particular winter. Now, it's interesting to note that while the northern hemisphere, and the hemisphere is half of a sphere. So when the northern hemisphere is in summer, the southern hemisphere is in winter. And the opposite over here. When the northern hemisphere is in winter, the southern hemisphere is in summer. And so their seasons are exactly opposite of us. Neat little graphic right here. It kind of shows you as the Earth is moving around the sun, you've got that particular angle on the Earth's axis, and it kind of shows you how the sunlight differs in the orbital pathway. And you can watch these graphics, and down here it's showing you the amount of sunlight and solar radiation that's hitting different parts of the Earth as the Earth moves around the sun throughout the year. And you get the months up here. Okay, so couple terms that go along with a revolution or the movement around the sun. Number one is a solstice, and that is when the Earth is either tilted towards or away from the sun. If it's tilted towards the sun, that particular solstice is known as the summer solstice, and if it's tilted away from the sun, that is the winter solstice. So think of the solstice as times of extremes. Either you're pointed towards or away from the sun. The second definition is an equinox, and that's when you're in between summer and winter. So your axis is not pointed towards or away, but it's kind of in the middle. And so you're getting relatively equal amounts of sunlight in both the northern and southern hemispheres. And so those particular seasons are called spring and fall. Here's our summer solstice in the northern hemisphere. You can see that if the sun is over here to the left, the sunlight is coming in and bathing the northern hemisphere, and so the northern hemisphere is going to be during the summer season, and the summer solstice, when we have the most intense sunlight, the longest day is June 21st and 22nd. When we are pointed away from the sun, we're going to be at our winter solstice, which is December 21st, 22nd. That's the first day of winter. June 21st is the first day of summer. December 21st is the first day of winter. And a little bit more information here on this particular slide. You can look at that one for yourself. Again, a picture of the winter solstice. You can see here's the sun over to the left. At this point in time during our revolution, we're pointed away from the sun, so we're getting less sunlight. And that would be during our winter solstice in the northern hemisphere. Summer solstice for the southern hemisphere. Okay. Because of the Earth's tilt, the poles are going to be either receiving more or less sunlight during these solstices. And so during our winter solstice, when we're pointed away from the sun, you can see the North Pole here is in darkness. And so the North Pole has 24 hours of night during the winter solstice. But because the southern hemisphere would be slightly towards the sun, they would be bathed in sunlight the entire time. So they'll have 24 hours a day. Just some neat things about how sunlight and hits the Earth and reacts with the Earth, and some different factors there. Okay, the equinoxes are, like I said earlier, is basically in between the extremes, and so your angle, even though we're still at 21.5 degrees of tilt, this is relatively perpendicular to the sun. And so you're receiving relatively equal amounts of sunlight in both the northern and southern hemisphere. And so the dates here are going to be the dates for the beginning of spring and fall. So March 21st in the northern hemisphere is the spring equinox. September 21st for the fall equinox in the northern hemisphere. And this graphic kind of gives you an idea of what's going on during the equinox. You can see that we're basically at a perpendicular angle to the sun at this point in time. Okay, while the Earth is moving, there are a couple different motions that take place. One of them is called precession, which is change in the direction of the axis. Now, right now, our axis is pointing to a star called Polaris. We call this the North Star. But over a course of about 26,000 years, our precessional axis, or the Earth's axis, will slowly rotate. And this video right here will show you why that takes place. And so I'm going to let you watch the video. I'm not going to sit here and play this video for you because you can watch that one on your own. So, the precession is a change in the direction of the Earth's axis. In about 13,000 years from now, our precessional axis will change enough that it will be pointing towards a different star called Vega. And right now, Vega is what we call our southern star. But in 13,000 years or so, as our axis rotates around, it will be pointed towards Vega, and then that will be our northern star. Watch the video. It'll explain it better than I just did. Now, nutation is a wobble due to the pull of the moon as the Earth is rotating around the sun. And so this pathway kind of outlines the pathway of the axis. And as the Earth rotates, it's got a little bit of a wobble to it, and that's because the moon is going around the Earth, and it causes it to shift just a little bit. So what can happen here is the axis of rotation can vary from 21 maybe to 23 degrees and maybe down to about 18 degrees or so. And so that's going to cause a change. That's going to cause a change in the extremity of the seasons. If you increase the angle of the rotational axis, what's going to happen is your seasons are going to get more extreme. If you lessen that axis, your seasons will become less extreme. And I'll try to explain this a little bit more in class as we go. I'm running out of time, I'll try to explain more of these things. We've been about 13 minutes into the video, so I'm going to stop here at this point in time. I'm just about through with this slideshow anyway, and we'll pick up with Barry Center in a different video. All right, look forward to seeing you in class.